In the last video, we'll be talking about transformer, where we cover how energy is carried through wires to the household, what step-up transformer we're doing, why they work only in AC and they cannot work in DC, and what are step-down transformer is opposite to step-up transformer. One single thing I wanted to point out is that I also have been talking about the groups, but I only draw, basically only make drawings about monophase transformer. So this is relative only to one phase, and this one as well is relative only to one phase, but we have three phases. So you can even have, well, you can basically have three of them arranged in different configurations. That's why you have different groups. Now, according to how they are arranged and which configuration they have, and basically the angle gets different, the phase angle gets different, and so on and so forth, between the phases and so on and so forth. The reason for this video though is that what I've been saying is valid for ideal transformer. Now, what's an ideal transformer? Well, an ideal transformer is something that I just described, basically, something that gets the job done and that's it. However, not only in the real world, in real world application, we would have resistances in the cable, and the cable has a certain resistance, as I pointed out before. But inside the transformer, we are also gonna have losses because of the copper due to copper and iron. Why do we have losses? This is a nail. Yeah, it's pretty bad, but why do we have losses? Because of due to copper and iron. So in the copper, so inside the copper and inside the iron, in the copper and in the iron. Well, we do have those losses because of something funny, which is called eddy current. What are eddy currents and other kind of currents like passive currents and so on? But what are eddy currents? Well, we just said that a wire is gonna make it's basically the current flowing through a wire is gonna generate a magnetic field, and this other magnetic field, this magnetic field is basically gonna make the charges move and induce a current in the other wire. Everything is fine, but we assumed that this magnetic field was going to be, just like that. It's independent, it's perfect, it's going to make the charges move. There's nothing going to be and interfere with that. But in the real world, there is. Here, I'm just going to draw at the top. Do you have a color? Yeah, I'm just going to use this. We're going to have currents that, I messed up I messed up. I messed up the drawing. Anyway, we're going to have currents that are not intended to be there, but they're still going to be generated because of the flow of current or because of the magnetic field. And those currents, since nature hates change, they're going to be opposite to the basically to the flow of current, so to the induced magnetic field, because the material that we're going to use for the transformer is basically, it's not something that is, you know, completely isolated and doesn't do anything when the current is going to go through it and so on, but it's going to do something. And those currents, those non-intentional currents, are going to be generated and are going to be opposite to the flow of current. So in a real world application, so in a real transformer, we're going to have losses be in the copper and in the iron, which are the two elements that are basically going to be into a transformer. So there are many ways, different ways in which engineers have developed different workarounds in order to make those kind of currents as small as possible, but they're still gonna be there, and they're still gonna be in the opposite direction of the flow of current, because this is something, you know, this is something that it's pretty logic, because, you know, if you make if the flow of current makes generates a magnetic field that is going to be in the same direction and is going to, you know, help the current flow, then we will actually have infinite current, because, you know, we'll have the current flowing and the magnetic field, you know, contributing to the current flowing. We will have infinite current. But no, those currents that are generated are going to be opposite to the flow of current, because, as I said, nature hates change. So yeah, we have to keep those things in mind when we are talking about transformer. So this is why an ideal transformer is way different from a real transformer. Another thing that we're gonna consider when we're talking about ideal versus real transformer is that the magnetic field affecting these other wire, it's never 100% like concatenated with this one. Like it's not perfect. It's not gonna be, you know, the resulting, the result of this generated magnetic field is not gonna be perfectly like, it's not gonna act perfectly on this other wire. So that's another thing that we're gonna keep in mind. It's not gonna be perfectly, like perfectly. I'm not gonna say coupled, because it's not coupled, but like perfectly in reason. Yeah, it shouldn't be using resonance. But you know, it's not. Just keep in mind that it's not gonna perfectly affect the flow of current in here, and there are many different reasons why it may not be, you know, as I said, perfect. So yeah, keep in mind that ideal transformers are way different from real transformers.